So welcome to the next session. In the last lecture we were talking about the system. The system was a simple system, a moving coil galvanometer converted into a voltmeter, and we were expecting that the voltmeter scale is adjusted by using the series resistance such that for 1 volt there should be 10 degrees of deflection of the pointer, and therefore we wrote the equation as theta O, that is the system which is having the deflection of the pointer as output, that is the angular position is the output and voltage is the input. So theta OT is equal to 10 into V in T was a naturally written system equation, but we concluded that since the system output, that is the pointer deflecting, is having some limitation of maximum speed, then if input is changing at a speed more than the maximum speed of the output, naturally the pointer will, or the angular, what is the conclusion? It is expected that the angular position of the pointer of the voltmeter should be directly proportional to the input voltage. But if the speed of changing input is more, in that case the output angular position will not be maintaining the proportion with the input voltage. Then what will happen? So naturally this is ruled out to be the correct equation. So when this is ruled out to be correct equation, the question remains, what is the equation then? What will happen? What would be the changes in the input-output relationship? So if I change input at a rapid rate, the output will not be able to follow that. Now, I think that in the first year, everybody must have seen, or everybody must have studied the subject of basic electrical engineering. In the subject of basic electrical engineering, or you are also aware of the electric voltage which is AC, that is alternating. AC is alternating current, then AC voltage is what we can say. In that there is nothing like AC voltage, but AC is considered to be a well-known term for alternating things. So if I have got this voltmeter which is having center at 0 and 45 degrees, this is 4.5 volts minus, this is plus 4.5 volts, and if I connect an input to it, is of AC plus minus 4.5 volt peak to peak, means VAB will increase from 0, will go to plus 4.5, will decrease, come to 0, will become negative, go to minus 4.5, and then it will continue in a sinusoidal manner which you are aware of, and it is having a frequency in how much time it completes one cycle from 0 to 0 covering both things, or from one peak to that peak back, that is its period, and 1 upon the period is frequency. So there may be our supply frequency is 50 Hertz. You can increase it. In US it is 60 Hertz. You can reduce it. You can have a signal generator which will generate the AC signal of variable frequency. You can change it right from 1 Hertz, 10 Hertz, 20 Hertz, 50 Hertz, 100 Hertz, 200 and so on. In that case, if 1 Hertz is the frequency, what will happen? That voltage will now, I don't know whether you have done some experiment on using CRO, maybe in 11th, 12th also, or maybe in first year. So that's, if you connect this input to CRO, and CRO can be in XY mode. CRO can be in XY mode. If CRO is in XY mode, where you don't connect the other input, only connect one input, in that case the voltage is shown by a point on CRO, and when voltage increases, it will move up, it will move down, move up, move down, move up, move down continuously. Then CRO, now we are having digital storage CROs, these are different, but the old, in physics you might have done the experiment of electron beam. In old CROs where this spot is because of the electron beam bombarding on the screen. So that electron beam is deflected depending upon the voltage, and this voltage is also connected to this CRO. Then the electron beam is a physical phenomenon which can move very rapidly. So this mechanical pointer can also move, but there is a limit on its maximum speed, and regarding electron beam, it can move very, very rapidly. So what will you find? When the frequency is 1 Hertz, then the point will move slowly up, slowly down. This would be, again there is a scale. This is plus 4.5. This is minus 4.5. This is 0. This is 0. This is plus, minus. This is plus. So what you will see on the screen of CRO, the point is moving from plus 4.5 to minus 4.5, and here now this would be some. So here we adjusted the CRO scale that this distance is 4.5 centimeter. This distance is 4.5 centimeter, so that there is proportionality of 1 centimeter per volt. So this is linear position. It is moving in a line. It is moving with an angle. So on CR, so we have applied this voltage to two systems. First is moving coil galvanometer. Second is CRO. In moving coil galvanometer, the output is angular position of the pointer. On CRO, the output is angular position of the electron beam of the spot. The spot, white spot, everything will be blue, and the white spot will be there indicating the position. So that is, so here the scale is 10 degrees per volt for this, and there 1 centimeter per volt. So 4.5 volts will lead to 4.5 centimeter displacement, and 4.5 volts will lead to 45 degrees of movement. So this is 10 degrees per volt, output is angular position, and here 1 centimeter per volt, output is linear position. Now this is a system which is very fast. It means the beam can change at a very rapid rate, but the pointer can't move beyond a certain rate. So when the frequency is low, what will happen? This will move up to 4.5, minus 4.5. This also move on these sides. Now I am asking a question. You can put a pause and think, and then again resume and verify. What will happen as I go on by keeping the amplitude of plus minus 4 volts as same? if I go on increasing the frequency, from 1 hertz to say 2 hertz, 5 hertz, 10 hertz, 20 hertz and so on. So what will happen? As I go on increasing the frequency, the speed with which the voltage changes increases. When the speed with which the voltage changes increases, the pointer has to move at a rapid rate. This also has to move at a rapid rate. So in this case, what will happen is, if say 100 hertz, 200 hertz, 500 hertz, 1 kilohertz and so on. So in that case, this cannot move at it. And what is happening now? Suppose if that, just we can take an example. This being an interdisciplinary subject, especially for other than electronics and electrical, I am giving very simple and examples. So, very simple, it means I am giving so simple examples that you will say, oh, this subject is so simple. Listen very carefully. Suppose that I think in the first year induction program, you have done some physical activity. Like that, there is some physical activity to be conducted, and there is a, what you can say, Kho-Kho, you must have heard about. There are 2 poles in the Kho-Kho ground, and I just put one center pole. Not center pole, center position. I marked the center position. 2 poles are there. Now, what I do, I instruct the student. The student is at the center position. I instruct him, go run, now run and catch the right hand side pole. Now run and catch the right hand side pole. Then obviously the student is obedient, he will go and try to catch. Once he catches right hand side pole, now I will tell, turn around and now go catch left hand side pole. He starts running, catches that, and I ask him to repeat. So we will go to right hand side, left hand side, and that will continue. But now what if I do that he is at the middle position, I order him, now go to the right hand side pole, he starts running. But now what I think is that I change my mind and I tell him, now go to left hand side pole. Then he was going to right hand side pole slowly. In between I interrupted him and told him to come to left hand side pole. So before he reaches right hand side pole, I told him to reverse. So he will start coming towards left hand side pole. Then I say him, oh, now again you come to right hand side pole. And if I change my instructions so rapidly, what will happen? The person at the center point will move few meters right hand side, few meters left hand side, and he will oscillate. If I am enough slow, he will oscillate between the poles, full Kho-Kho ground. If I increase my speed of instructions, asking him to change the directions, what he will do is he will not be able to catch it up. Then this is the example which is not so complete, because what I did is that what is the difference between this example and this? I told him, I instructed him, catch the right hand side. That is not. So now, listen very carefully. I am trying my level best. To explain the things in such a simple manner. Again, let us imagine same Kho-Kho ground, 2 poles, center position. Then, what I do is that I am at the top of the center position, maybe from some other side, just like basketball ground. Just like basketball ground, you have got a basketball pole and that you are at the top. So Coco ground, 2 poles, center position, and I am at the top of the center position. I'm at the top of the center position. And I have got a laser pointer. I got a laser pointer in my hand. And I have just put it straight down, so that is center point. Now what I say, that I will move my laser pointer. I will change the position. So that red spot which is the center will move towards the pole, towards this pole. And the student which is here is expected to follow the laser spot. It is perfect description of this. I am at the top. So this is so simple, so day to day, that you will never forget in life, even if you want to. I want that some fundamental concepts to be embossed like tattoo, permanent tattoo. You can't get rid of it, even if you want so. You need to have plastic surgery. So I am at the top and I am moving the laser gun. So the laser spot is moving and the student has to catch it. Naturally, everybody of you will agree that I can move the spot at any rate, and there is a limitation on the student. There is a limitation on the student with the speed with which he can catch the spot. If I am moving spot slowly, students will walk easily and catch the spot. If I start moving spot at higher rate, he will run, but I can still go higher. And if I move the spot at a much higher rate, then what will happen? So I am moving the spot at higher rate, the student can't catch that. So he is trying his level best slowly. So what I am explaining it in so simple words. Here is the middle point of the Coco ground. Here is one pole. One pole, other pole. So here is the laser spot. And the laser spot I am changing at rapid rate. What the student will do? Student will try to run. But if I am moving the spot at higher rate, which student can't catch, but the student is obedient, so we will try. So what will happen? Naturally, what will happen? The spot will be ahead than the student. Then, when the spot reaches here, the student might have reached up to this point only. He started running to this point. Then what is happening? Then the spot is moving back. Spot is moving back. So he is running, spot moves back. So he knows that now I need spot has moved the end, I have reached here. Spot is moving back. What my will follow the spot, I go. I still go because means what is my role? As an obedient student, you try to catch the spot wherever you are. Wherever you are, you try to run with maximum speed so as to follow the spot. So the spot has moved at a rapid rate, spot is coming again. So when spot is moved here, I am here, spot is coming here, I am still moving here. Spot comes here and spot goes on this side, so I turn and I run here. Spot goes here, spot comes here, so what will happen? Spot is moving between two poles. I am unable to cover that distance because of my limitation. So I cover a small distance. So if the speed of laser spot movement is much larger than maximum speed of the student in the span, the spot, the student, what is system? System, input to the system is position of the laser spot. Output of the system is position of the student. Both are linear positions, scale is 1:1. Input is position, output is position, unit scale. But the spot will cover entire copogram, the student will cover small portion. And as the speed, if I increase speed too much, then the student, obedient student, what he will do? He will go here, he will go here. So or if we say that why to turn, I can walk like this, so he will walk, so he will be just vibrating there. So that is the ultimate case. Same will happen here. As the speed, the frequency of this AC is increased, this is electron beam, so it will cover same distance. Even if it 1 Hertz, same 2 Hertz. Only thing is that because of persistence of vision, I can't see the movement of the spot, I will see the entire line as such. And here it will go like this. As frequency increases, it will reduce, and at around 1 kilohertz, you will just hear that this is moving like this. So what is happening? Because of the limitation of the speed, angular speed, the maximum angular speed with which the pointer of the galvanometer can move, so the entire conclusion is that the equation with which we started, that theta OT is equal to 10 into V in T, is not a correct equation. So what is signal and system? V in T is input signal, theta OT is output signal, and that permanent magnet, that moving coil and the resistance is the system. And the entire purpose on which this subject is building up is establishing the system equation for between output and input, and this, which is system equation we have considered, is not there. So output cannot be sometimes input, because for any system in the world, input signal is the cause and output signal is the effect. Listen very carefully. Input signal is the cause and output signal is the effect, and whenever cause-effect relationship is there, cause-effect relationship cannot be instantaneous. So instantaneous position, instantaneous angular position of the pointer of the voltmeter cannot be proportional to instantaneous voltage or input voltage. Instantaneous output angular position cannot be proportional to instantaneous input voltage because of cause-effect relationship. So cause-effect relationship can't be instantaneous. It is the universal law. No system in the world can be of this type. Now the question is, if this cannot be there, then what will be there? What will be there? What will be the system equation which will satisfy by and large the observations? So one thing is that how we have arrived at 10 degrees per volt when we have connected 4.5 volts and kept it fixed. When we have connected 4.5 volts and kept it fixed, we have observed that we get the pointer showing 45 degrees on my right hand side. So 45 degrees for 4.5 volts. So I said that 10 degrees per volt. So output is 10 times the input and the unit is degrees per volt. But somehow this theta OT, which I said 10 V in T, is not possible because of cause-effect relationship. If this is not possible, then what is possible? It's very interesting question, and if you are able to think on this question in detail, or rather the entire subject is thinking on various aspects of this question. What will be the perfect equation of angular position of voltmeter and input voltage? What this equation is not true all the time. This equation is approximately true if the input is constant or changing at a negligible speed. It is, or to be very precise, it is called as a steady state equation. So if you apply 3 volts, you will get 30 degrees deflection. If you apply minus 2 volts, you will get a minus 20 degrees deflection. So you have to keep it constant. So this is called a steady state equation. But this is not a real time equation. Steady state, if you don't change, it is all right. But if you change, this equation is not holding good. So, whenever there is cause-effect relationship, there is inertia. So that input voltage causes some current to flow. That current produces some magnetic effect in the electromagnet prepared because of the coil, which is placed in magnetic field created because of permanent magnet. So permanent magnet moving coil, and because of that coil moves. So all this thing takes time. Therefore, now listen very carefully. Because of this cause-effect relationship, some kind of dependability on previous things, this concept is introduced. Because of this cause-effect relationship, some kind of dependability on previous things is introduced. Then I will ask, if this can't be an equation, then will this be a correct equation? Theta OT, what we said initially, that being cause-effect relation, it can't be instantaneous. So should I say theta OT is equal to 10 into V in T minus some delay of delta T. Some delta T. Prima facie one may say yes, it's okay. It's a very good equation and it will work. Is it clear? Cause-effect relationship can't be instantaneous. So this is impossible. Then the question is whether this is possible. Means this is something which we thought to be true but not true. So its changed version is this. Because of some delay, in the cause-effect relationship, the delay is introduced. Will it work? Will it work? You may pause, think and come up with answer. Many may feel it will work, but it will also not work. Why? Because it is just delayed. Why we started that there is a problem? We said that the voltmeter constructed with a moving coil galvanometer is having an inherent limitation, and there is a limit on maximum speed with which it can move. And when we delay, if input is moving at a rapid rate, the output also expected to move at the same rate, only some time lag is there. So if it is changing here at a rapid rate, output also should change at the same rate, only with some 1-2 microsecond delay, and that can't happen. There is a limitation on the maximum speed with which output has to change. So this is impossible. Then what I again say, cause-effect relationship can't be instantaneous. Also, cause-effect relationship can't be means something which is opposite to instantaneous is delayed. What I said, cause-effect relationship can't be instantaneous. Simultaneously, not being instantaneous does not mean that it can be a delayed relationship. Cause-effect relationship can never be instantaneous, nor that it can be simply delayed relationship. It is not so. Means in instantaneous relationship, the output depends on input at that instant, and in a delayed relationship, output at given instant depends on input at some previous single instant. That is also not possible. Then what is cause-effect relationship? Cause-effect relationship is because of a cumulative effect. I explain. So what you are today is because of something which you have listened just now. It also depends on something which you listened few minutes back. It also depends on something which you received few hours back, and so on and so forth. So, to be very precise, this is the most important part of this entire subject. The cause for any system, input signal is the cause. Input signal is the cause and output signal is the effect. Input signal is the cause and output signal is the effect. So that cause-effect relationship can't be instantaneous, it can't be simply delayed. Then what it is? It is, effect is not depending on the input just now or some time back. It is cumulatively dependent on the input in some previous time. Listen very carefully. So the correct I am not coming to the final answer directly, but we go towards the answer slowly. So the voltmeter which gives me 30 degrees for 3 volts, 20 degrees for 2 volts, that the degrees per volt is 10. So that 10 has to be there somehow, equal to theta OT. So output angle is 10 times the input voltage, but not instantaneous voltage. 10 times is also correct, and into some kind of cumulation. so that I say average of V in T over some time. What exactly we will see in detail. This is the theme what we are having. And so what I say, over some which time, it can't be depend on next sum. So I am just changing some previous time. So as an example I can write theta OT, just as an example of this, is equal to 10 into average of VT over last 1 microsecond, or to be very, micro is too fast, 1 millisecond. What is the deflect output angular position of the pointer of the voltmeter? Output angular position of the pointer of the voltmeter is 10 times average of input signal. So output signal depends on average of input signal over some past time, over 1 millisecond. And a good voltmeter will have this time as less. A poor quality voltmeter will have this time as more. So 10 times average of VT over last second. So the output is depending on average of input. Now, as this is a theme, just see, this is not the final thing. This is just to tell you about how exactly things work. Signal, input voltage signal, voltmeter system, output angular position signal. So output signal is 10 times average of VT over last 1 millisecond. Now, there will be many lectures. I will try my level best to make the things so simple, so clear to you that even after decades of passing out, if somebody asks you the question, you must be able to answer same thing. I will be bombarding it to such an extent that you cannot forget it. Even if, means once you listen, you have to understand, means I have a technique of enforcing understanding by using simpler and convincing terms. So this is something which looks good. Now what will happen? If input is changing slowly, what will happen? If input is changing 1 hertz, that the 1 millisecond is averaging period. If changes in the averaging period are not so large, in that case output will follow input. But if input is changing very rapidly, that during averaging, most of the changes are lost. So if I have input signal and I have average signal, if input signal is changing slowly, the input signal and average signal will be of approximately same. If input signal is changing rapidly, then the average signal will not vary to that extent of input signal. You can plot any input signal. I will try my level best to show you what will happen. We can take a sinusoid. if I have got a sinusoid which is changing slowly, this is approximately 25 milliseconds, this is 25 milliseconds, 50 milliseconds is the period. So a 20 Hertz signal. If it is a 20 Hertz signal, then 1 millisecond average. So if I average this over this 1 millisecond, average will be here. Next millisecond average will be here. Next millisecond average will be here. So average signal will be approximately same signal as the, like this somewhat. Outputs average signal will be same as input signal. But if this is 5 milliseconds, this is 5 milliseconds. So 100 Hertz, in that case 1 millisecond. So this one, this one, this one. So it would be very small. The average signal would be very small. And if this is 2 milliseconds, so 250 Hertz, then this one and this one. So this average is same. This one. And if I move the average, then it would be very small. So if input is changing at rapid rate, the rapidness of the rate is indicated by whether significant changes are taking place in the averaging time. In that case, the average signal would be very slowly varying. All the input changes are lost. So if I'm averaging at one, slow or fast depending upon averaging time. Slow or fast depending upon averaging time. If you are measuring the height of some plant, measuring height every week is a good period. But if you are measuring height of a 10-year-old boy, then there is no point in measuring every week. Measuring one after every 2 months would be sufficient. So that the time interval of averaging or taking readings depends upon the speed. So if the signal is moving at a rate such that the changes happening are significant in averaging time, then those changes are lost. So averaging destroys the changes. Whereas if signal is slow enough that in averaging time, not much details, not much change is there, in that case the averaging doesn't distort the signal. So obviously the output will be able to follow the input. So a moving coil galvanometer, voltmeter will follow the input to a large extent when changes are slow, because the averaging time is 1 millisecond. Now remember, this is just introduction. Then in further lectures we will see the details. Now the question is that what is something which we see wrong? Output is 10 times. We said input, it will not happen. We said delayed input, it will not happen. Now we are saying input is 10 times average of VNT over last 1 millisecond. Then is it like this, that exact last 1 millisecond averaging is done, nothing previous? It is not so. It is not plain average, to be very precise. Right now I am just giving you introduction, and in the next lectures to come we will deal with it. It is just, I am giving you just glimpses, just touching the issue. The output is 10 times average of VT, but it is not plain average. In fact, when you consider what you are today, it is because of what you received just now to a large extent. Means your response depends on majority on what you receive now, then to some extent on previous thing and so on. So in fact this average is not plain average. So average, when I count here at this point, I say last 1 millisecond. So this area I say. So this average. This divided by this base width. So it is not like this. So it's a weighted average. This is called as convolution. It's a very important term in signals and system. So it's weighted average over, not last 1 second, it actually, what I am today is because what I received yesterday, day before yesterday, day at the time of my birth, day, the time before my birth, and if you can continue, in my previous birth. So it's an infinite thing. Weighted average over the past. So this is the weight curve. I am here at this point because of this. I am here. The average is with this weight current input, with this weight previous 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 input. In mathematics M2 you must have learned a term convolution. So out this you may not understand to actual extent right now, but just carry it with it, that the output is 10 times weighted average of V in T over the past. That's a very broad term. Output is 10 times weighted average of V in T over the, to be very precise, entire past. This is Introduction to Signals and Systems. In next lecture, we will work on another very important system. The example which I am taking is of water model. In electricity, you have knowing voltage, current and charge. Voltage is water level, current is water flow and charge is actual water. Because current is rate of flow of charge. Similarly, flow is rate of flow of actual water. So actual water quantity is charge, water level is voltage, and water flow, you might be knowing now Q6, that is quantity per time. Water flow is current. So these all things are related. And for resistance, for conducting wire, a pipe. A pipe is a conductor. Actually, conductor wire is superconductor, but it is not so. It is having also some resistance. Similarly, a somewhat say 1 inch pipe is enough, a good conductor. And what is the resistance? Valve. You can control the valve opening. So more opening, less resistance, less opening, more resistance. So in the next lecture, when we see water level model and actual system, you will understand what exactly different types of systems mean. So in that, water is equivalent to electric charge Q, voltage is equal to water level L, current is equal to flow, and resistance is equal to valve opposition, that I say O. So with this, water quantity, water level, water flow and valve opposition, you listen next lecture, in which most of the thing would be amply clear to you. So I think today we have learnt enough. Let us stop here. Thank you.